Hello everyone, welcome to a brand new science video. Just a quick reminder guys that this video has been sponsored by freesciencelessons.co.uk. Now today's topic is organohalogen compounds in the environment. So what are they? Organohalogens are a class of organic molecules with at least one halogen active group. Chlorine, fluorine, bromine, iodine and acetylene. They're relatively stable molecules. An example of one would be PCN, short for polychlorinated naphthalene. It is a stable molecule used for waterproofing, fireproofing wood, paper, textiles, etc. More uses could be solvents, dry cleaning solvents, refrigerants, etc. Now, environmental and health impacts. Well, originally it was thought that due to their stable nature, halocarbons were not dangerous. However, they are now known to be dangerous. Let's talk about CFCs for a minute now. Chlorofluorocarbons. They break down ozone in the atmosphere. CFCs are molecules that have had all their hydrogen replaced by chlorine and fluorine. They're stable molecules but are broken down by UV light. Now what we have here is a free radical reaction, but before we jump into that, let me just describe you that. For example, CH4, methane, that would form bonded with 2 fluorine and 2 chlorine. That's an example of a CFC. And that any of the bonds can be broken down by ultraviolet light. Let's jump into how they can be destroyed by ozone. As you can see, it's a radical reaction. It breaks down to form chlorine radicals that catalyze the breakdown of ozone. So you have initiation, a molecule will react with ultraviolet light and it will form 2 radicals. And then these, in this case we're using chlorine, and this chlorine radical, it will react with ozone. And it will, in this case we're seeing that it forms a ClO free radical. And this ClO free radical will form another chlorine radical, and then in termination we see that these 2 radicals react to form CO2. So in this case the Cl free radical is reformed and it acts as a catalyst. Probably wondering why ozone and oxygen are circled red and blue. It's pretty much just showing that how in the reaction ozone will form oxygen, as the product is not that difficult. Now, health risks. Before we jump into health risks, let's quickly mention other radicals that destroy ozone. Nitrogen oxides formed from vehicle emissions, and also thunderstorms can destroy ozone. For example, every nitrogen oxide, it will react with ultraviolet light, and then you get an NO free radical plus oxygen. In this case, we're going to use R as the radical formed in the initiation step. If that confuses you, I'm not surprised. So nitrogen oxide plus UV light, you get NO free radical plus oxygen. Now in the propagation steps, you get NO free radical and react with ozone, and you get an NO2 free radical plus oxygen. Then this free radical, which is NO2 free radical, will react with oxygen only, and that will form NO free radical plus O2, and the oxygen is formed when the UV breaks down the O2 in this case. Now, so health risks. Now in mid-1920s, the workers involved in PCN observed to suffer from chloracne. In the 1930s, they began to suffer from liver failure. In the 1940s, a big molecule was shown to kill insects. And 1970s, we see another 2 large molecules, which I cannot say, have been thought to potentially cause various health complications. These are the health risks. Now, environmental risks. DTTs and PCBs, they can contaminate ecosystems such as the Arctic ecosystem contamination. Common halocarbons such as the refrigeration ones and like non-stick pans, they can accumulate in the atmosphere and they can damage the ozone layer. Finally, the breakdown of organohalogens can create dangerous byproducts like hydrochloric acid or hydrofluoric acid. Now the laws, although many developed countries have banned compounds such as these like DTTs and HCHs and other dangerous organohalogens, they continue to exist in the environment and cause adverse effects. Now that is all for today. Thank you all so much for being ever so patient, and I'll see you guys in the next one.